Good morning, everyone. Thank you very much for hosting us today, and many thanks to Mark for his presentation in advance of ours. So by way of background, SunPork has 52 piggeries across Queensland, New South Wales, South Australia and Victoria here in Australia. In late February, one of our Queensland farms was diagnosed with Japanese encephalitis, followed by one of our New South Wales farms the next day, one of our Victorian farms just under a week later, and 2 weeks after that, our first South Australian farm. Over the following 3 months, through to May 2022, we reached a total of 9 infected breeding herds nationally. These farms are entirely unrelated to each other and span a spread of over 2,000 kilometres in terms of distance between each other. Benny and I are just here today to share some of our experiences with Japanese encephalitis here in Australia with you. So I thought I'd start with a bit of a background to the Australian pig industry to you, just to provide some context. The short story is we are not a large industry. We are absolutely dwarfed by the North American industry. We have just over 3,500 farms nationally, heavily skewed, with around 50% or more of pigs held by 3% of those farms. We support around 32,000 jobs nationally and represent around 2% of Australia's farming outputs. In terms of meals, we make 700 million meals a year. And we always make sure we bring it back in Australia to the fact that our industry supports families and communities right across the country. There was a question earlier around the spread of the pig industry. This is the distribution of our breeding herd. It's 24% of our breeding herd is in Queensland, just under 23% in Victoria, 21% in New South Wales, 17% in South Australia, and 15% over in Western Australia. So there is a significant number of sows over in the West. I get in trouble if I don't include Tasmania, but as you can see, there's just a few sows down in the upper Isle there. In terms of how our herds are set up, around about 5% of our pigs are kept outdoors, and that is all stages of the life cycle live outdoors. Around about another 5% are actually certified outdoor bred. So what that means is that the breeding sows and boars live outdoors. The piglets are then moved indoors onto bedded systems at weaning. That leaves the vast majority of our herds, so over 90%, indoors and a range of different styles of intensive housing. So we're looking at one example here, which is a naturally ventilated style of housing. We have tunnel ventilated systems, as you can see here. And then we also have some bedded systems that are within that intensive farming style set up here. 80 to 90% artificial breeding by either AI or post-cervical AI, fresh semen deliveries 2 to 3 times a week. We have good biosecurity, similar to the US in terms of biosecurity is a priority for us. It's an increasing priority with diseases like African swine fever and FMD on the border. And what I would flag specifically with reference to JE, because I guess even with the best of biosecurity, it is difficult to battle things like mosquitoes. But one thing I would highlight is from an epidemiological perspective is that the large majority of our breeding herds are either closed entirely to live introductions, or if they are accepting replacement breeders, they're going through a 4 to 8 week off-site quarantine period, which should cover a viremia for JE. We have a voluntary quality assurance program administered by our national pork body, Australian Pork Limited, that addresses food safety, traceability, animal welfare and biosecurity, with additional optional verification units for gestation store-free and for compliance with Coles, which is one of our large retailers. It's a very robust system. It's mandated external audits every year, with internal audits as well. There's 121 core standards within the APIC program, of which 29 are dedicated to welfare, 17 to biosecurity and traceability. And since the middle of this year, we now have a specific standard addressing the requirement for mosquito control in certified piggeries. In terms of compliance with APIC, just under 90% of the national sow herd is sitting within that APIC system. And of the enterprises over 500 sows, well over 95% of herds are sitting in the APIC system. However, There are a large number of very small holders or pig keepers that are not certified. So again, speaking back to that skew that I mentioned earlier, the vast majority of pigs in Australia and sows are sitting on quality assured premises, but there are many smaller holders that are not. So that's just some background to the pork industry. Now, just briefly, some background to JE, and I do apologise for any overlap with Mark, and I also apologise to the substantial expertise in the room if I'm telling you things that you already know. So, as many of you would be aware, Japanese encephalitis virus is a arbovirus in the flavivirus family. The flavivirus family also includes yellow fever, dengue, and Zika. And here in Australia, as Mark mentioned, Murray Valley encephalitis and West Nile virus are on the radar for us. They are spread by mosquitoes. In Australia, the primary mosquito implicated in the spread of JE is Culex annuli rostris, although trapping activities this year have actually implicated some other species, including Culex gelidus. Japanese encephalitis has a natural sylvatic cycle with native wild waterbirds from the Ardeiid family as hosts. Now, these include the herons, the egrets, and the bitterns. However, we would caution that in Australia, the role of different bird types in JV epidemiology remains largely unknown. So very much what's going on here is that we're inferring from overseas experiences what might be happening here in Australia. Infection of humans, horses and pigs, as Mark mentioned, it's considered to be a spillover event. It's not part of the natural life cycle. Humans and horses are dead-end hosts. They don't generate sufficient viremia to infect new mosquitoes. Pigs, however, do generate quite substantial viremia. They can reinfect mosquitoes, and then thus not only an amplifying host, but an epidemiologically very important host. Now, the first documented case of Japanese encephalitis in a human was in Japan in 1871, hence the name. In Australia, as Mark mentioned, we had 3 cases of genotype 2 JEV in the Torres Strait Islands off the north of Australia back in 1995. That was followed in 1998 by another 2 cases, one again up in the Torres Strait and the second on the mainland at Cape York. In the years since, there's been no cases at all until March 2021, when there was that fatal case in the Tiwi Islands that Mark mentioned, which was the first genotype 4. Now, that was just under 100 kilometres off the coast of the Northern Territory. Japanese encephalitis is nationally notifiable disease in both humans and animals in Australia, and recognising its significant implications for human health, it is classified as an emergency, a Category 1 emergency animal disease. So just here, you've no doubt all seen variations on this, but this is just showing that sylvatic cycle there between birds and mosquitoes in the centre. You've got the spillover into horses and humans in a dead end sort of style on the right, and that amplifying cycle through pigs down there underneath. Now, in the general context of flaviviruses, as Mark mentioned, Australia is no stranger. You can see here both Murray Valley encephalitis virus, which is in the yellow, and West Nile virus in blue. They are known to be present across large parts of the country. However, back in February of this year, which was quite a nice time in February before this all arrived, Japanese encephalitis virus was only a known risk for the very far northern tip of the state of Queensland. And it was not considered a risk. As you can see it here pink down through Asia, it certainly wasn't considered a major risk on the mainland of Australia. So as you can see here, it was just a risk up in that far northern tip of the state of Queensland. Now, that thinking changed very, very suddenly. As Mark said, it was a quite stressful Friday night, late in February, when within 24 hours over the 25th and 26th of February, we saw Japanese encephalitis diagnosed almost simultaneously by several different veterinarians at totally unrelated pig farms across New South Wales, Victoria and Queensland, followed just days later on the 3rd of March by the first farm in South Australia as well. Now, all outbreaks at that time and since are of the genotype 4 virus, which is, as Mark mentioned, consistent with that human case in the Tiwi Islands back in 2021. Now, it is known that genotype 4 is endemic through Indonesia and in Papua New Guinea, which, again, as Mark mentioned, are immediately to Australia's north and really not that far away. By the end of March, just over a month from that first diagnosis, we had more than 50 infected piggeries across the eastern seaboard of Australia and extending down into South Australia. And by the middle of 2022, we had over 80 farms infected nationally. So it really did go from zero to boom very, very quickly. So in the space of a week, we went from that little blip you can see in orange to headlines like this nationally, where we had every state in the country involved in the outbreak. Now, Mark has shown this slide, but I'll run through it again. You can see the heat spots here representing the distribution of infected piggeries across the eastern seaboard and then over into South Australia. In all, we've had 18 piggeries in Queensland, 13 New South Wales, 23 in Victoria, and 10 in South Australia confirmed infected during the response this year. There have been 2 human cases in Queensland, 13 in New South Wales, 10 in Victoria, 5 in South Australia, and 2 in the Northern Territory. Sadly, 7 of those human cases have been fatal. There have been 25 positive detections in feral pigs in the Northern Territory and 4 detections in feral pigs in Northern Queensland. There's been 1 fatal case in an alpaca in South Australia. Mosquito trapping has identified JEV positive mosquitoes at 3 locations in Queensland, 3 locations in New South Wales, and 7 in Victoria. Positive mosquitoes in Queensland were detected as recently as May this year. And retrospective testing has identified 1 piggery in northeastern Queensland that was actually positive back in April 2021. I'm going to hand over to Bernie now, who's going to speak to some of the clinical manifestations of the outbreak.
Thank you, Kirsty. Yes, I'll continue the story. This is not a happy story. So what we've got here on this slide is a representation of the herd data for our first diagnosed herd, which was in Queensland. And that represents the litter outcomes at farrowing for a small cohort. The picture immediately to the right of that is of the physical outcome. Mummified fetuses, quite spectacular, which you would not miss in a production sense, with some deformities. In advance, please, Kirsty. More herd data from the same herd. This represents the litter outcomes for this herd, with these numbers being the number of mummified fetuses born in litters from that herd. The numbers don't matter too much, but what it represents, I think you can see from the pattern, is quite a dramatic increase over a short period of time in the number of mummified fetuses, of litters having multiple mummified fetuses. Next slide. So what did we see on farm? Well, healthy sows. We saw nothing suspicious at all in the sows themselves in the breeding herd. No fevers, no off feed, nothing that would raise a suspicion of any illness. We started to see delayed farrowing, so extended gestation times commonly over 118 days in affected litters. Reduced litter size, some increase in returns to service, and some late term abortions as well. Next slide. And this was the money shot. A gruesome family photo. I would draw your attention to the right-hand side of that picture and the size of the mummified fetus. This was an indication to us of what we were assuming was the time of infection. So this litter was from our first farm. That photograph was collected on the 19th of February from that farm. We consider that the smallest mummified fetus in this picture would be maybe 40 to 50 days of gestation, which would put the time of infection at early December 2021. with a progression there of fetal death all the way up to a fully formed stillborn piglet. We did come up with our own case definition at the time, which was a significant increase in mummified piglets in an individual litter. So more than 4 mummified piglets, more than 4 stillbirths, and a low born alive, or some combination of that. And the deformities as well. I'll have some more pictures coming, but quite spectacular gross deformities. Next slide, please. Here we are. I think Mark stole this one from us. You've seen it before. But again, look at the bottom right of that picture and the size of the smallest mummified fetus as an indication of infection time. This is all 1 litter. And we've got pretty much the range happening here. We've got mummified fetuses, we've got stillborn fetuses, and we've got deformities. Next one, please. More deformities, more gruesome family photos. Something striking was the leg deformities or the limb deformities, so arthrogryposis and some hyperostosis we saw, which was in the initial few litters, but we did not see that as a feature as it progressed through the herd. But the arthrogryposis certainly was there, which I have since learned is a neurogenic lesion rather than a physical developmental lesion. Next one, please. This little video playing away there, this was, we had shaky piglets, and retrospectively, we know that our herds pointed this out as possibly the first indication on the farms. We had piglets born normal size, normal gestation, normal numbers, no increase in stillbirths or mummified, but we had these neurological deficits in piglets. They're shaky, no fine muscle control, poor survival, and they were born dumb. They wouldn't suckle, these piglets, so they were euthanized. And on the left there, we've got a histological description, histopathological description, which was from that piglet in that video. So that piglet was sampled. I happened to be on the farm when we saw that one. And that was the finding. And again, we have since learned that some of these descriptions are possibly, I wouldn't say pathognomonic, but are certainly very indicative for Japanese encephalitis infection, particularly the last bit, the gliosis, neuronal necrosis, malacia, and the mineralization of neural tissue. Next slide. And this was probably the most spectacular lesion. I don't think you'd miss this on a full necropsy of a piglet. Fully formed piglets with no brain, an absence of neural tissue in the cranium. And there was fluid there. And sampling, the first positive diagnoses were from samples of brain fluid. Next slide, please. A bit of the unhappy tale of production, or of the spread of infection, at least, on 4 of our farms. So the first samples that I took, first diagnostic samples, which was that shaky piglet you just saw, that happened to be in mid-January. So what I'm depicting here is, this is the percentage of affected litters as looked at through the production outcomes of farrowing. So stillbirths, mummifieds, and pigs born alive. So for this farm, on a weekly basis, each dot represents the farrowings for the week and the percentage of affected litters. And the red square indicates when the diagnostic samples were collected from this farm. This is in, that time period goes from about last October 2021 through to end of March, I think it is, or April, mid-April 2022. On the right-hand side is the location of that herd. That one's in New South Wales. And click through, please. The next one, the next lot of diagnostic samples were collected from one of our farms in Queensland. That's the red dot there. That was the one with the spectacular mummy outbreak. They did not see a lot of deformities or stillbirths, but they saw the whole mummified fetus, litters born. Quick. Victoria was the next one, herd in Victoria. And again, they saw a spectacular increase in affected litters. And by then we had a pretty good idea of what we should do. So diagnostic samples were collected quite quickly. And lastly was South Australia as an example. This herd, they saw a lot of stillborn and not so much mummified fetuses in this herd. And it was a gradual increase. So it kind of, I wouldn't say took them by surprise because they were on the alert for these clinical signs. But it was the last one of these 4 anyway, of our herds that we collected diagnostic samples from. So different presentations in these different herds as well, which was interesting, and a different level of how affected the herds were. Next slide, please. So what that translated to over the period of time, so these are the same data, percentage of litters that are affected by JE on each of those 4 herds. So that translates to about a 9% decrease in pigs weaned. Next click, please. If you consider the sole goal of a breeding herd is to wean pigs, wean healthy pigs, and they each have their weaning budget, their weekly wean number that they target they're hitting. And this graph on the right represents the deficit that that each herd had to their weaning budget on a weekly basis. So that represents about 9% for that time period. That's from start of January through to about mid-June, I think it is, or yeah, mid-June 2022. About 9% decrease in weaned pigs for those 4 herds, which translates to about 13,000 pigs that we did not wean from those herds. Next one, please. Oh yeah, there it is. January to end August. Some other observations. This photograph here, talking about birds, I don't know much about birds at all. I know even less about wild birds and waterfowl. This photograph was taken by me at the first herd that we had diagnosed, and I was standing at the end of the gestation shed, the gestation barn, and that's just some standing water. That's not effluent water, that's just standing fresh water, runoff water. Those birds are about maybe 100 meters from the end of that shed, from that gestation barn. I think, if you click through please, Kirsty. I think there was at least 4 different types of birds, and they're standing in water, they're wading, so I assume they're some kind of wading bird. Also, things you find out is that our state government health departments had established mosquito monitoring systems, and these data were taken from the New South Wales monitoring system, which is publicly available. They publish the mosquito monitoring, and they have set trapping places around the state, and they look for abundance of Culex, particularly Culex mosquitoes. These 3 trapping sites that I took from the website back in March, I think it was, I took this. These 3 trapping sites are the most proximate, geographically proximate to the herd where those birds were on the left. With the bottom one, if you can see it there, a town called Gleeson, being about 50 kilometres from where this herd is located. And the green squares indicate that they did not find a lot of mosquitoes. The red squares indicate they found a lot of mosquitoes. Bearing in mind that, as I said previously, we think the initial transmission of JE to our breeding pigs probably was in late November or early December. And what this information indicates is that there wasn't any signal of abundant mosquitoes at the time. Next slide, please. A bit more of the story. This is our Queensland herd. This graphic represents our Queensland herd, and this was the at the time of the initial outbreak, where we had a significant increase in mummified fetuses and litters born with all mummies. The 4 grey bars represent the 4 gestation sheds of gestation barns of that farm. And in the initial outbreak, the initial cohort of sows, I looked at some herd data because we had information of where those sows were in gestation, where they were located in the farm in gestation. It's all group housing, so no gestation stalls on this farm. All pigs are group housed in pens, and across the farm it's 26 gestating sows per pen. So looking at just the case definitions that we had, where we had affected litters and non-affected litters from pigs in the same pens. They were co-housed in the same pens. Don't really know what to conclude from this, except that it seems that pig-to-pig transmission was not a thing. But also it really raises the question about transmission at all to some of these pigs. Why were some affected? Why were some not? These are all the same cohorts, so they were gestating at the same time. Would also point out that the topmost shed in that picture, that graphic, is a naturally ventilated shed. And if you imagine further to the top of the slide is where there's water, the effluent collection, and also some standing runoff water is to the top of that. The bottom shed, the bottom group there, that is a tunnel vent shed, so fully enclosed. And eyeballing that information, looks like there was not much difference in transmission between the two. Next slide, please. Just some other observations on semen abnormalities. One of the herds has an internal bore stud, so they collect and process semen within that farm for use within that farm. So we were able to get some information on semen abnormality. And this represents on the left of that graph there, the weeks of semen collection and the number of pigs, number of boars collected, and the ejaculates, with differentiating between less than 60% motility and more than 60% motility, just as some arbitrary cutoff for quality, as well as 0% motility. To have a 0 motility ejaculate collected is rare. It's not a common thing at all in normal healthy boars. And on the left there, we had an increase in this small bore stud of that. As for the sows, there was no abnormalities noticed with the boars. There was none off feed, no fevers, nothing unusual at all was noticed. We also have a small amount of initial serology that we were able to collect from one of the affected herds, where when we're on farm, we knew that there was some affected litters born and some non-affected in the same group. So only these few we collected serum from, and we found that the affected ones were positive for JE and the non-affected were negative. And interestingly, the sow 7, the 7th sow sample, only had one stillborn pig, but that pig was PCR positive for JE, even though the sow was serologically negative. Next slide, please. Effect on subsequent reproduction. This was a major question that our pig farms asked very early on, is what's going to happen, because we had to attempt to continue with our pig production in the face of fairly poor production with on the JE affected herds. And we had to make the decision, did we rebreed sows? Did we go ahead and breed gilts? And what would be the effect subsequently on those? So we did, we rebred sows that were affected mostly, if they were not otherwise in line for culling. And so this represents the outcomes of their subsequent breeding. So in the initial lot of the JE affected sows, we had a born alive per litre of somewhere around 5 or 6, with the Victorian herd affected really took a hit at 3.4. And in the same cohort, the non-affected born alives were around about the 12 pigs, as you see there, per litre. Those same sows, the ones that were rebred and subsequently farrowed, we have the data there for them, and they've essentially returned to normal. There is some effect, probably a pig born alive less, something like that, although you'll notice the South Australian herd actually had an improvement in pigs born alive on the JE affected sows compared to the non-JE cohort, which we don't have an adequate explanation for that, but I'll just leave that there as an observation. Other subsequent effects, this shaky weaner pig is the only verified post-weaning effect that I have from a JE affected litter. So this was from a farm that individually identifies every pig at birth for breeding purposes. And so we knew that this pig came from a JE affected litter. And he's got a bit of a tremor. It was an excitation tremor. You didn't notice it when he was asleep in his pen, and when he was disturbed, he'd had a very slight shake. And also the last observation we had, I just have, if this works, oh yeah, there we are. This video was taken from one of our farms in May 2021. We didn't get to perform too much in the way of diagnostics on this litter, but there was definitely some kind of neurological deficit happening in these pigs. There was incoordination, there was trembling, there was shaking. They were born normally. There was no excess stillbirths or mummified pigs, but it's all lost to history now. We don't know if this was some kind of indication that we missed, or we don't know what it was.
Right, so back to me, and I'm nowhere near as interesting as Bernie. Just speaking to impact of the clinical manifestations you've just seen, we're unsure of the true extent of impact across the nation, but we know that in some states, over 50% of sows are in infected herds or formerly infected herds. And we estimate that up to 60% of the national industry has been impacted in some way. So based on a 30% reduction in pigs weaned over a 10-week period, we're estimating that the average impacted herd will see annual losses of up to 6%, largely a result, as Bernie indicated, of reduced pigs born live and increased pre-weaning losses. So in a financial context, this equates to financial losses of around 350 to 400,000 Australian dollars per 1,000 sows, or up to, by my calculations, around $250,000 US per 1,000 sows. There has been a reduction in pigs being processed through our systems of somewhere between 3 and 6%. We're going to struggle to ever really quantify the extent of this decline due to the fact that producers and operators are shuffling pigs around to meet the markets and to fill gaps. But there is most certainly a disruption that has transpired, and it does continue to have impacts through the supply chain right up to current, and we're expecting it to keep going. At an individual farm level, we would flag with you, and Bernie's demonstrated it quite clearly, that the clinical presentation and impacts do vary considerably between farms. So the numbers in this slide here very much are general and indicative only. Just to speak a bit more to that variation, and there's a slight difference here to some of the work Mark presented. This is an industry perspective that's been prepared by a collaboration of Australian pig industry veterinarians, including ourselves. What you can see over on the left here is that the estimated earliest and latest transmission periods, which are based on the clinical presentations in the pig herds, they're reasonably consistent across the states. Transmission seems to have started in spring, not unsurprisingly, and continued through to late autumn. What is interesting and surprising and borne out by Bernie's slides is the amount of variation you see between farms. So you can see here in the middle that for some farms, transmission and by extension clinical signs are appeared to be over a really short period. So it could be as short as a month or so, where for others, the impact, well, it really just seemed to go on and on and on. And for some farms, it did go out well beyond 6 months, as you can see here. Further to this, across the infected farms, the percentage of litters affected varied markedly. It could be anywhere from less than 1% of litters to well in excess of 50% of litters. And the extent of this impact didn't seem to be influenced by where the herd was, the size, the duration of transmission across the herd, or really anything else that we can put our finger on. And I guess our conclusion is that there's clearly some local, very local piggery level risk factors contributing to these outcomes that we just don't yet fully understand. So how is the response played out from an industry perspective? Essentially what we've had is two responses running in parallel. We've had the animal health response and the human health response. So initially the response was an animal health lead. In Australia, we have a national disease response framework, which has provision for cost sharing under a deed known as the Emergency Animal Disease Response Agreement. There's also in line with this a pre-agreed approach to each disease called AusVet Plan. The balance of the cost share varies by disease based on the relative impact to human health versus animal health. And you can just see some examples here of the different diseases in their cost share categories. And you can see that they vary from something largely human health related like JEV, which has a heavily government cost share, down to something like equine influenza down in category 4 there, which you can see has a predominantly animal health cost weight to that cost share. So in parallel with that animal health response, on the human side, on day 6 of the response, so this was very early March, the chief medical officers declared Japanese encephalitis to be what they call a communicable disease incident of national significance, so a CDINS. And with that, they enacted their own plan called CD Plan. Now, under this framework, the response actually switched from being an animal health lead to being led by the federal government Minister for Health and reporting through them to the National Cabinet and the Prime Minister. Now, as some perspective for you, the only other CDINS to occur in Australia in the past 10 years has been COVID. So it was certainly taken very seriously. So we've had these two responses running in parallel, the agricultural and the health response. There's been excellent collaboration between the two and between both of those with industry. They've been nationally coordinated, but they're actually operationalised or implemented at a state level. And both responses have had shared priorities between them that have focused on, firstly and foremost, keeping people safe. There's been the development of effective, safe mosquito management guidance for piggeries, for abattoirs, and for horse owners. There's been efforts to keep pigs and semen moving. There's been a range of different surveillance activities initiated, and it seems the more we learn, the less we know. But as some examples in this space, we've had the serological surveillance activities that Mark mentioned, looking to better understand the extent of spread. And we've also had some serological work across some of the infected premises to understand that sort of local behaviour of JE within infected herds. And of course, there's that really important piece around public information. In particular, the message that pork is safe to eat, that JE is a mosquito-borne disease, that pigs are an incidental host, and very strong communications around mosquito precautions for people, pigs and horses that, as Mark mentioned, are going to need to continue. What does it look like for an infected, like an individual infected premise? Well, upon being confirmed as being infected, there's 4 things that really happen at a farm. There's mosquito trapping and testing, which is overseen by our human health colleagues in the first instance. Trapping's had varying levels of success across the country, anywhere from 0 mosquitoes to 4 or 5 that you could individually name, through to tens of thousands of mosquitoes. And there's been various outcomes to actual JEV testing on these mosquitoes. As a general comment, our observation would be that mosquitoes are a far less sensitive indicator of the presence of JEV than the pigs themselves are. There's been mosquito control activities undertaken at all of the infected premises. These are the responsibility of the farm themselves, but they are required in order to move pigs. I'll speak to this a little bit more in a moment. There's been risk assessments and permitting to move pigs and semen, which I'll also talk to in a moment. And importantly, there's been vaccination of people working at or residing on infected premises, which is again overseen by our health colleagues and is ongoing. So this is just a image here of a mosquito trap along the tree line at one of our piggeries. If you squint really carefully, you can see the pig sheds in the background. Mosquito trapping was initially the domain, as I said, of our health colleagues. More recently, it started to become a function that pig producers are directly engaging in themselves, though still with close engagement from health to make sure we're doing it properly. Mosquito control, to put it bluntly, we weren't doing it very well, if at all, prior to JEV arriving. And the industry had a very poor understanding of the fact that effective mosquito control involves much more than going around fogging to try and kill adults. It's about breaking their life cycle, as you can see here. So managing sources of standing water to reduce locations where eggs can be laid, treating the water that you do have to limit the development of larvae, and thirdly, applying chemicals strategically to kill those adult mosquitoes. Now that all sounds really straightforward, but this is the type of thing we're dealing with. So this slide is just to give you some idea of the scale, both at the very small end of town on the right and the big end of town on the left, of the amounts of surface water Australian piggeries now have to consider with respect to mosquito control. On SunPork Farms in Queensland alone, we have over 229 hectares of standing water that we now need to plan regular mosquito control for. And on top of this, every new rain event brings aggregations of water, like you can see here, that need to be considered. Now, those larvae that you can see in the middle have actually come from that little tiny pile of water at the base of that fence post on the right. Now, we've had substantial rain events across Australia through 2021 into 2022, and it really does feel like it's just La Nina on top of La Nina on top of La Nina. And the images that you're looking at here are very much the everyday for most Australian piggeries at the moment. Now, as part of the response, we've seen the development of national guidelines around the control of mosquitoes around piggeries. The development of one of these, it was a really excellent One Health collaboration between medical entomologists, agricultural chemical expertise, and industry to provide guidance that was not only effective for mosquito control, but it was also safe and safe for pigs and people. It was legal for use in food producing species. It considered things like chemical residues in meat. It looked at the actual availability of product and the practicalities of using different ones on farm. And it also, the guidance drives to recognise non-target species and mitigating impacts on things like waterways in our surrounding. So you can see here on the left, a comprehensive guide to whole of life cycle mosquito control. This document also includes a list of chemicals that can be used safely around pigs and piggeries. On the right, we just have a general awareness resource for piggery personnel on controlling mosquitoes. And then just here in the middle, you can see an extract from a beekeeper advisory that was produced to raise beekeeper awareness of JE control around piggeries to help them mitigate their risks with respect to the JE outbreak and our control activities. Moving to pig and semen movements, and I know there was a few questions on this earlier. In the first 5 days of the response, so this is back that first week in March, movements halted. We didn't move anything for the better part of a week. Since that time, though, movements of both live pigs and semen out of infected premises have largely been uninterrupted. For semen. There's been minimal disruption to business and absolutely no animal welfare repercussions for the industry. There are some conditions in place for the movement of live pigs, as you can see here. Now, the objective of these is to manage the risk to human and animal health by minimising the likelihood of naive mosquitoes at the destination of a journey being exposed to Japanese encephalitis virus. So what this is really driven toward is minimising the risk of either putting a viremic animal on a truck or having an infected mosquito jump along for the journey. Now, farms that were infected this year no longer require permits to move pigs, but in the place of permits, they now have legally enforceable biosecurity obligations to manage the risks of JEV at their premises. And importantly, as I mentioned earlier, we have the vaccination of people associated with those infected premises. Now, all people who work at, live at, or provide services to piggeries, pork abattoirs, and pork rendering plants in Australia are eligible for subsidised vaccination. More recently, in the last month or so, this eligibility has been expanded to include pig hunters and also to include people working outdoors in areas where transmission of JEV is considered to be a risk. So that extends to those areas that Mark mentioned earlier along the river, for example. Now, the cost of this vaccine is fully subsidised by the Australian government for those people that are eligible. Just briefly following up on Mark's comment around vaccination for pigs, down the base there, you can see those trials with the inactivated Japanese genotype 3 vaccines that are underway. Separately to that, there is an industry-sponsored vaccine under development. It is a recombinant vaccine, which is using an insect-specific flavivirus. It's the Binjari virus. It has the replication genes of the Binjari virus and the coat proteins of JEV. Now that vaccine has just gone to very early trial stages. We don't expect to see vaccine this year, but we are hopeful that we may have a vaccine early next year with some luck. So just moving on from the response and from those activities that have been undertaken at infected premises, I'm sure there's few surprises in what's to come here, but we just thought it worth touching on as we finish up here some of the risk factors for JEV from an industry perspective, from sort of our lived experience of this. First up, we have water. We have lots of water. As I mentioned earlier, we have significant quantities of water. It's also very close to the pig sheds themselves. We have both fresh water and effluent water within very close proximity. And in addition, a lot of our effluent systems are underfloor and they're draining out. So we actually have a water source directly underneath the pigs themselves. Again, this one is just to demonstrate that the volume of water close to the piggery doesn't necessarily mirror the size of the piggery. You can have small piggeries with lots of water and large piggeries with not so much water. Regardless, we have substantial quantities of water in very close proximity to our pig populations. We have the water birds, as Bernie mentioned. What we don't understand is which species are relevant, whether they're, what abundance they're in, at what proximity to piggeries, and what role they may or may not be playing in the outbreak that we've been dealing with. Bernie's mosquito monitoring data will attest to this. We know we have competent vectors in Australia. We absolutely understand that. Our question is, have there been more mosquitoes through the 2021-2022 season? And from an industry perspective, our experience would say no and would support the trapping activities. When we have large numbers of mosquitoes, we get carcass damage from bitten pigs, and we haven't seen that at all this year. So what we seem to have seen is not so much a change in the quantity of mosquitoes, but a change in the nature of that population, in that they're carrying Japanese encephalitis. What we are staring down the barrel of going into this next season is these ongoing rain events, and it's very much a perfect storm coming into summer this year. And we are expecting that there may be horrendous levels of mosquitoes. And in fact, we're hearing reports back from our farms already nationally, from Queensland right through to South Australia, that they're struggling with mosquitoes even during daylight hours at the moment. From an industry perspective, we don't think that pig movements are playing a significant role in the epidemiology of JEV in Australia. We have pigs from at least 4 commercially unrelated genetic types impacted across the national outbreak. There are no movements between these farms. They're just totally unrelated genetic companies and related businesses, that there's just no movements between those farms. We have, as I mentioned earlier, most of our infected breeding premises are either closed to live introduction, so it would be a physical impossibility for pigs to move it in, or where they are open to controlled introductions. Those introductions go through an off-site quarantine period that would well and truly be long enough to cover the viremic period of an animal carrying JEV. We have infected premises that in some cases are breeding replacement gilts. And then we have downstream herds from those that have remained negative throughout the outbreak. And we also have, in 2 cases, genetic nuclei that have been impacted, and we have multiple examples of customers of those herds that have remained negative for JE. So we're not seeing any evidence that the movement of pigs is playing a major role in the epidemiology of this outbreak. Likewise, we're not seeing evidence that semen is playing a major role. Mark did refer to restrictions around semen movements. What he's talking to there is the movement of semen into Western Australia. We have 8 major boar studs in Australia. They're all high biosecurity. They supply between them 80 to 90% of the national herd. So each is supplying somewhere between 35 and 60,000 sows. They're supplying fresh semen 2 to 3 times a week. And this is how they're doing it. So semen is traveling in every different direction between states. And those arrows going across to Western Australia, we're going right up to the date of that first diagnosis. So if you're thinking about the reproductive manifestations being a lagging indicator, there was semen going into Western Australia right through the transmission periods over in the east. And there was certainly no transfer in semen over to Western Australia. Unfortunately, they do maintain some restrictions now on semen movements into Western Australia, but from an industry perspective, there's been no evidence to suggest that semen has moved JE anywhere. The boar studs at the major boar studs were all, the boars were all semen PCR'd early in the response and were all negative. And what's interesting here is that some of those boars would have originated previously from infected premises. As Bernie mentioned, infected boars have a slight problem in that they tend to be aspermic. The boar stud quality systems would not allow for that semen to ever leave a boar stud. It needs to be over 60% mobile and have correct morphology to even make dispatch. And in addition, nationally, we have a huge range of customers from all of the boar studs. Some of them are positive, some are negative across all states for all boar studs. And as I mentioned, coming out of a range of different boar studs in the east, there's been no transmission into the west. Other risks. I just really wanted to finish off on this one, and I am noting that we're starting to stretch the limits of our understanding and possibly jumping over into a little educated guesswork. We have very limited evidence based on a comparison between 2 infected SunPork farms that might suggest, in some cases, a protective effect of housing. So what you can see here in this slide is the serological results for the progeny lines from 2 different farms. At farm 1, the sows are in naturally ventilated sheds, as are the growing pigs from around 12 weeks of age. Now, what we believe we're seeing here is evidence of maternal immunity in those younger pigs, suggesting reasonable level of exposure in their mothers that may be associated with them having reasonable exposure to the environment. And that is consistent with seroconversion that we have seen in those sows. I just haven't shown the sow results in this slide. That maternal immunity then declines and we see natural exposure start to come into play for those older pigs. In farm 2, by contrast, which is the one down the bottom, the breeders are fully enclosed in housing, as are the grower pigs up till just before 12 weeks of age. So in this farm, you can see there's no evidence of maternal immunity, but we do start to see that what we think is that natural exposure and seroconversion in those older pigs. So in this case, as I said, it's still a bit speculative, but we do wonder for these herds whether the enclosed housing in that second herd has had a protective effect on it by comparison with that first herd. However, we would strongly caution that you not generalize this kind of assumption. At best, it may be a local effect between these particular herds. We're certainly aware of herds where the sows are indoors in ventilated sheds that have been hit pretty badly. And as I said, possibly it might just be us grasping at straws as we really grapple with the unknowns of JEV at that actual piggery level. Just another little quirky anecdote as I finish up. There have been quite a number of reports across states, across vets and across enterprises of concurrent skin disease in infected herds. So things like swine pox, erysipelas and greasy pig disease. Again, this might be totally speculative, but I guess we'd question, could there be a relationship? And if so, what might it be? We know that fowl pox is spread by mosquitoes in poultry. We know that erysipelas is experimentally spread by mosquitoes. And we know that greasy pig can be spread by some ectoparasites. So again, this might be a nothing, or it might be something that potentially could be a bit of a trigger for us into the future, given that we struggle to actually see the disease itself when the pigs are viremic. So just to finish up, what have we learned? Well, the first thing is never, ever underestimate just how many things can go wrong at the same time. So in February, we were dealing with the back end of COVID. The same week as JE hit, the Ukraine was invaded. That's had a catastrophic impact on feed prices and cost of production over here in Australia. Japanese encephalitis hit at the back end of that week. Queensland flooded that weekend catastrophically. Followed early that next week, as we were having our first national meetings about Japanese encephalitis by New South Wales, including the New South Wales State Diagnostic Laboratory. It was shut for some time there during that flood. Shortly after that, they called our federal election, which meant that we went into what's called caretaker mode, which means that a whole lot of decision-making cannot happen, including a lot of things like budget allocation and whatnot that were potentially important to undertaking some of the response activities. And what's slightly terrifying is that that's what happened this year. And as Mark alluded to earlier, this is what's happening right now in Victoria and New South Wales. Here in Australia, we have cataclysmic flooding, one in 200-year event happening at the New South Wales Victorian border. So it doesn't seem that these events are going to let up anytime soon. More generally, we've learnt that pigs are highly sensitive indicators to the presence of Japanese encephalitis virus. Unfortunately, though, the reproductive syndrome is retrospective, so we're not detecting transmission until well after it's happened. We had 4 vets representing 4 different enterprises across 4 different states in Australia simultaneously diagnose Japanese encephalitis. This tells us that the pig industry, veterinary and health monitoring systems here in Australia, and I dare say in North America, are highly effective and very responsive when it comes to rapid detection of disease. For the veterinarians and agricultural emergency responders in the audience, we've spent the last 2 years in Australia solidly engaged in preparation for African swine fever. And we can assure you that not 1 second of that was wasted. So it might not have been African swine fever that arrived, but nothing in that preparation was wasted. And the work that we've done for African swine fever absolutely underpinned the collaboration we had with government during this response. And we've absolutely learned that relationships, understanding and credibility between government and industry stakeholders is pivotal to having a successful emergency disease response. Very importantly, and as some food for thought for everyone at this conference around what comes next, we've also learned that there's an awful lot that we just don't know. So starting at the beginning, as Mark mentioned, Japanese encephalitis did not read the textbook in Australia. It isn't behaving as we thought it would behave. And it's just one of many examples. There's very limited evidence across a whole lot of herds of widespread seroconversion. So we don't understand what's going on in these herds. The role of birds is a great big black hole for us. And we're not just talking about the expected or inferred species. It's the whole range of species that may or may not be playing a role in the outbreak that we've seen and may continue to see into the future. The role of different types of mosquitoes. We get told time and time again that it's Culex and Nilirostrus. But there's a whole range of foul water mosquitoes that potentially could be inhabiting some of our effluent systems, for example, and other mosquitoes that need to be explored to better understand the role of different types of mosquitoes in JEV in Australia. Regional factors, what is it that differentiates at one area from another in terms of propensity to JEV outbreaks. We've got some ideas there, as Mark mentioned, with the river and whatnot, but we need to understand better what's going on there. Really importantly, what's going on inside the piggeries? What could possibly explain the diverse range of presentations between piggeries, not only in, as I mentioned earlier, the extent of transmission, how long it's going for, but the extent of impact. We certainly can't see anything obvious that's explaining to us why some piggeries are getting hit really badly and why others that may not be too far away aren't being hit anywhere near as badly. Genotype 4, is it different to the other genotypes? Has it got different climatic preferences? Is the pathogenesis different to those genotype 2s and 3s that we're perhaps more used to dealing with? The pathogenesis of JEV in pregnant sows and gestating litters is one that is a constant source of conversation for veterinarians over here with pathologists. We have lots of great ideas around what we think is happening in the uterus, but we really don't understand the pathogenesis of the virus and how it's actually manifesting in those litters. We need better diagnostics. We need to start looking at leading versus lagging indicators. Waiting for those affected litters is not only costly, but it means that the transmission risk has largely been missed from both an animal health and a human health perspective. So just a few things that we're starting to look into. We're looking at wastewater testing and testing of bird feces, so environmental testing. We're looking at abattoir surveillance, and we're looking at validating oral fluids testing as an alternative method of surveilling animals. And the great big question around what's going to happen this year as the rains fall and the summer approaches. Thank you very much for your time and for putting up with Bernie and I.
Bernie and Kirsty, thank you very much. That was fascinating presentations. Are there any questions in the audience, please? And indeed, if you do have a question, please lead with your title, name and title, please. Yes, Paul.
Sure. So Bernie, Kirsty, this is Paul Sundberg with Swine Health Information Center. First of all, thank you for the collaboration and the transparency and the willingness to share all this information. From the very start of this thing in February, your willingness to share information about the outbreak has certainly helped us and it's very much appreciated. My question is about vaccination compliance. The human vaccination for people working in the piggeries is available. What's the take-up? What's the compliance with that?
It's an interesting one, actually, Paul, in that we were slightly terrified coming on the back of COVID and all it went with vaccination around COVID. And uptake has actually been really good as long as you make it easy for people to get vaccinated. So uptake is not an issue, I would suggest, and Bernie, please jump in, accessibility is the bigger challenge. So where people have to drive 100 or 200 kilometres to get a vaccine, they're less likely to do it. But where we've been able to coordinate with local medical clinics and have vaccination clinics. So in one case, we had 70 people vaccinated in a day. In another case, a provider actually went to our abattoir and vaccinated on site. We've had really good uptake in that case. And the challenge going forward is going to just be making sure that new people coming into the industry continue to get vaccinated.
Yeah, exactly that, Paul. If it was available and convenient, the uptake was great.
Megan, yes, please.
Hi, Bernie and Kirsty. It's Megan Niederwerder from the Swine Health Information Center. Thanks so much for your presentation. I had two questions. One is if you could speak on the specialization of your hog industry as far as from our farms mostly farrow to finish, our farms mostly farrow to wean, and the impact of maintaining the hogs on the same site after infection and what that did if they were supposed to be moved to, let's say, a nursery or a grow finish phase, and what was the resolution to that, if that was an issue. And then my second question was just based on the PCR My assumption is that the initial diagnoses that were made in February were based on the historical PCR that you had available to you, that's primarily been based on genotype 3 and 2, and looking at, did that pick up genotype 4 to a similar extent, or what you expected?
I'll speak briefly to the genotype 4 and then I'll throw to Bernie for the production question. Megan, I'd encourage you to raise this again with David Williams tomorrow, but our understanding is that after the Tiwi Islands case, they actually made some modifications to the Australian PCR to allow it to, like, in recognition of the genotype 4. So we were lucky to an extent that that previous case had happened. The system was primed to be detecting genotype 4. Had that Tiwi Islands case not happened, it's possible that it would have taken longer to work out what was going on.
And to the production types, Megan, it varies. The larger herds, so let's say 1,000 sows and greater, tend to be multi-site, so farrow to wean and then finishing elsewhere. But that's not the case. Certainly 2 of our infected herds were farrow to finish. And what that meant for during the outbreak, thankfully, given the type of response that we had, so the official response, the movement restrictions did not have a production impact. It was tight because there was 5 days with no movements. It was certainly getting tight, but it didn't have any big impact finally with it. And ongoing, we don't think there's a difference in transmission dynamics to the breeding herd. Again, we're speculating here, we don't really know, but given the variation in production outcomes we've seen on our various breeder herds, of which the ones that I showed, there was farrow to finish and there was breeder only in those herds. We don't think that it being farrow to finish or not is any kind of predictor for the severity of the outbreak.
And Megan, just to clarify a point Mark made, we were able to continue moving stock between epidemiologically related farms. So there was no issues after that first 5 days with moving progeny from a breeding site to a nursery or a graft finisher site. What were heavily constrained movements were movements from between unrelated enterprises. So it really didn't have that backing up of pigs that I think maybe you're thinking we had.
Thank you.
John.
So this is John Drake from the University of Georgia. From the previous talk, I understand there were 84 premises affected, and from your statistics, it sounds like there are 3,500 farms. So somewhere between 2 and 3% of farms affected, so a minority of farms.
It's a bit tricky, John. Just remember that 3,500 farms would include all of your graft finisher sites where there's no clinical manifestations. So it would be impossible to actually meet the case definition.
Right, okay. So, I mean, in some respects, that's actually related to my question. And so my question is, have you been able to identify geographic risk factors, things like proximity to breeding bird colonies, standing water, this kind of thing, topographic information that actually distinguishes between affected and unaffected premises?
Short answer.
I'll
no.
answer it. I was going to say, I'll say no, and then Bernie can say no as well if you'd like. We'd love to know more, John, but we just don't. And you can have, but we can't explain it.
No investigation, or because investigations have not been able to turn up risk factors?
To some extent, the investigations are ongoing. So with the infected premises work, that looking at those risk factors would all be part of that, but the bloods are still being processed from those. There's just a fair volume of work going on, and we really haven't had time to stop and scratch, let alone really have a solid look at risk factors.
I would say, John, that the report of mosquito abundance by farm staff is very inconsistent. So some farms said, yes, we had a lot of mosquitoes. Some farms say, no, they didn't notice it. That's possibly because of the crepuscular nature of mosquito activity, but it's very inconsistent and we don't understand it.
And even to the extent, John, where one of our farms, the trapping activities trapped somewhere between 50 and 100,000 mosquitoes, and another trapping event at a different infected premise caught 4. So there didn't seem to be any consistency between, you know, it wasn't like you were routinely capturing or trapping large numbers of mosquitoes at these infected premises. Some they didn't catch any at all.
Before we go to here, Eric, any questions online?
Not yet.
All right, Harry, I know you had your.
Yeah, thanks. Harry Snelson with the American Association of Swine Veterinarians. Kirsty and Bernie, I'm curious, during that 5-day standstill, what was going on? What were they doing from an investigation standpoint? You know, why 5 days? How did they get comfortable with lifting that? Those sorts of things.
Well, I think 2 of the 5 days were unfortunately a weekend. And there was a state of emergency across 2 states of Australia concurrently to that. So the diagnosis happened on a Friday, the notifications happened on the Friday evening, and we sort of lost 2 days in there. But what was going on in those, certainly the Monday, Tuesday, Wednesday, was a whole lot of meetings and risk assessments to try and understand the extent of the situation and what would be the most appropriate risk-based decisions to make around things like moving pigs, moving semen. And I think there was concurrently, as Mark alluded to, a lot of work going on to communicate to health what a sensible risk-based approach to take to the animal side of things would be. So there was some concerted efforts to try and manage the potential fallout for piggeries that may have come had those conversations not happened.
And that a very big initial focus was on getting movements to slaughter happening, and a permitting system for that to happen, which really got through quite quickly.
It was one of the good things was it all happened virtually, so meetings were able to start and go for as long as they needed to go, with everyone not even having to necessarily leave their homes. A lot of people were flooded into their homes at the time. So as Bernie said, there was probably 6 hours of solid meetings on that first Monday and Tuesday to establish the movement conditions and agree them nationally, and have them reviewed and agreed by health in order to get those pigs moving.
David.
This is David Reeves. I'm a consulting swine vet here in the state of Georgia. And obviously early recognition of the disease within our farms would be hugely important from a standpoint of management. And I was particularly interested in the case of the mummy outbreak that you experienced on that one farm. There was no evidence of stillborns, arthrogryposis, shaker pig. There was nothing that was seen in that farm until you just had the explosion of the number of mummies.
I could say yes with the qualification, David. On retrospective examination of the herd data, there was a statistical increase in mummies about 4 weeks prior to the big outbreak. There was, you had to hold it up to the light at the right angle and see any change, but it was there and we missed it. It wasn't flagged. We missed that, and we have no idea now, because it's all retrospective, if that was because of JE. But certainly in that herd, no, there was no deformities or increase in stillbirth.
And the other question that I have that goes with that, but looking at the over the span of from the time of exposure, we would expect to see at least a 16-week period in which you would have the clinical signs, and then you would see that taper off. Is that what you normally saw happen within your farms?
No, not at all. And that's the conundrum, John. That farm you were just talking about with Bernie, it went up and it went down within the space of a month. But farms in the same state and elsewhere went for some of them. There was one that started in December and didn't stop until June, July.
Thank you. Any more questions? Yes, please, Abby.
Bernie and Kirsty, this is Abby Cannon from American Association of Swine Vets. Thank you for that clinical picture, super interesting. I was really pleased to hear how well the public information campaign went over. I had a question too on, I had seen an older report that there was some evidence of potential transmission between pigs and humans in tissue sample collection, cuts and abrasions on hands, things like that. Did you have any specific messaging for pig veterinarians, producers, anybody, lab, anything like that?
We did raise that with health, and we sought their advice, and their advice was just standard precautions in undertaking necropsies. They were a little bit more vigilant with horses and horse veterinarians and horse people, not so much because of Japanese encephalitis, but because Hendra virus was a differential. So they needed to be very careful that they covered that other base. But it's just general precautions and personal protective equipment, personal protective wear. That you didn't get any different messaging, Bernie?
No, it was all do what you normally do, which is protect yourself anyway and wash your hands. That was the message very early on.
Thank you. Other questions from the audience? Eric, nothing online? So, Bernie, Kirsty, thank you very much for presenting with us